Welcome to Learner's Choice. Today we focus on some basic calculations in CPU scheduling algorithms for deciding which algorithm is best suits for the given problem. So here we know some different algorithms like first come first serve, shortest job first, round robin and priority scheduling. So there are different algorithms. So before that we first concentrate the arrival time of a given problem. Before that we first concentrate the arrival time of a given problem. Here there are two cases. That is, the arrival time of all the processes are same, that is, at the time of 0 all the processes are arrived. And the second one is all the processes are arrived at different time, that is different arrival time of all the processes. So we do some calculations based on these cases. Generally the arrival time of all processes at a time 0 is little manageable, and calculations are also easy to do. But in different arrival time means we can concentrate more on calculation part. So at any way the basic ideas of calculating the things are same. First, for a given problem we have to concentrate well on the problem and what kind of scheduling algorithm mentioned in the problem, that is already we discussed, that is if it is FCFS, SJF or round robin scheduling or priority scheduling. And secondly we concentrate how many processes are there in the problem and their arrival time, that is if it is arrived at the time 0 or different arrival time. So these things are to be noted first. Then we have to tabulate the minimum data from the given problem like this. That is, this is the tabular column. So here that is process and arrival time, bus time. Then we have to be tabulate the minimum data from the given problem like this. So this is the tabular column, that is process, AT, that is arrival time, BT is the bus time, and CT is the completion time, and TAT is the turnaround time, and WT is the waiting time, and RT is the response time. So we have to tabulate all these things from the given problem, and so we should collect some basic minimum data from the given problem, that is process. Suppose if a problem consists of 5 processes, or sometimes it is 3 processes, or sometimes it is 2 processes, so we have to collect what are all the what are the number of processes or there means. Suppose if it is consist of 4 process means you have to write like this: P1, P2, process 3, process 4, like this. So after writing this one, then we have to collect the data, that is arrival time of all the process. Suppose that is already we mentioned, if it is suppose time 0 means all the arrival time of the processes or 0 means you have to simply write 0, 0, 0, 0, or sometimes the processes or that is the arrival time of all the processes or different means you have to write like this. Suppose process 1 arrived at time 4 means you have to write like this: 4. Process 2 means 3. Okay, then process 3 is 1 means 1. Process 4 is 6 means 6, like this. You have to tabulate the arrival time. So after the next column, that is BT. So BT is the bus time. It is also already given in the problem. So for example, process 1 burst time is 3, process 2 burst time is 7, and process 3 burst time is 6, and process 4 burst time is 2. So you have to tabulate these things. So these are the minimum data, that is we collected from the given problem, and we have to tabulate these things very essentially to extend the tabular column for further calculations. So then we concentrate if any time slice or time quantum, that is most important for round robin case. In case of time slice or time quantum. So both the terms are both are same term. So in case of round robin, we need this value, that is time slice or time quantum. We have to concentrate what is the time slice or time quantum, suppose if it is in round robin scheduling. So after tabulating the minimum essential data, further we extend the table by calculating the completion time. So it is otherwise called exit time. That is, the process completed its work in the CPU and get out of this out from the CPU is the time we called it as exit time or completion time. So both the terms are same. You have to use this one, CT or ET. So how can we calculate the completion timings? We first take a reverse look of the Gantt chart, which is the first step of finding solution of the given problem. I hope you know very well how to draw a Gantt chart of a given problem. So this reverse look helps us to find the completion time of all the processes, that is exit time of all the processes. Then we calculating the response time. After find out the CT, we just move to the last column, that is 1, 2, 3, 4, 5, 6, 7th column RT. So RT is the response time. So what is response time means? It is the difference between the starting time and the arrival time of the process, that is of all the processes. So we calculate the difference between the processes, that is the process whenever it is getting into the CPU and its arrival time. So we have to subtract these two values, that is starting time of the processes, and we find out the difference between the starting time and arrival time. Already we know the arrival time, that is the basic data derived from the given problem. So you have to subtract the starting time minus arrival time, you have to get the response time. So the next one is, after tabulating the values of RT, we just move to TAT, that is turnaround time. So what is turnaround time means? It is also the difference between the exit time, that is completion time minus arrival time. You have to take a difference between these two. You have to subtract the value of completion time minus arrival time, so that you have to get turnaround time. So after find out the turnaround time, we just move to the waiting time. It is very important. And the waiting time means it is very easy to find out TAT, then you have to move to waiting time, because waiting time is you have to subtract turnaround time minus burst time, so that you get waiting time. So now you complete these basic things of the tabular column, and it is very easy to calculate after do this process. And finally you have to find out the percentage, that is average turnaround time and average waiting time. So this is very important, average turnaround time and average waiting time of all the processes. So that you have to sum all these values and you have to subtract it by total number of processes. And here also you do the same thing. You have to add all the values, waiting time 1, 2, 3, 4 of the processes, and you have to sum all the things and you divide the thing by the number of processes. Here in our example it is 4, so you divide by this by 4 and you get the average waiting time. So this is the basic idea and summarization of all calculations of a given problem based upon a single algorithm. And There are a lot and lot of problems and important problems are available in this particular topic, and all these are to be continued in the next session. Thank you very much.